Okay, so basically conditional and unconditional probability is directly related to the independent and dependent events. Okay, mean to say that it applies to the intersection, how to calculate the intersections. Okay, one example is the dependent event, the conditional, which also known as conditional probability. Okay, the example is pick two M&Ms from a jar containing two red and three blue M&Ms. So the probability of getting a red M&M in the second pick is dependent on the first pick. So because in the jar they only have two red and three blues M&Ms. So of course the pick the M&M that we pick is totally dependent on the first pick. If let's say you pick the red and blue, so you're gonna have like another two blue and one red, for example. Okay, so this is the rule again, like I mentioned previously. So basically, sometimes you're gonna be given the value for this one, and sometimes you're gonna be given the value for the intersections. And of course, the PB usually is given. But please take note that usually, if let's say they want, for example, right, the question, name name the A given by B. So mean to say that the given by B should be B. Of course, right? Because you want to find the A. So of course you should have the value for B. So that's how you want to remember. Let's say you forgot which one is PA, which one is PB, just in case. Okay, next up is we have unconditional probability, which is the independent event. For example, is toss a coin twice. The probability of getting a hit in the second toss is independent of the first toss. Mean to say that no matter how many, or maybe no matter how hard, or maybe how much you tossed it, it's not going to influence your first or second toss, like really. Okay, for the independent events, we can, by definition, two events A and B are independent if and only if P, the probability of A given B, equals to probability of A, or the vice versa, probability of B given A equals to probability of B. Otherwise, they are truly dependent. So for the dependent, of course, you have to refer to this formula. Okay, I have a question here. Okay, let's say you toss a fair coin twice. Let's define the events. Hit on the second toss. Okay, so this is the tree that you usually have to draw. So because there are marks for this, right? So of course, don't ever forget to make a draw sketch on this, but make sure it's correct. Okay, for example, right? Of course, for the coin, you only have head and tail. So basically, you have head, tail, tail, right? Of course, because they only have two options. If let's say the dice, they have like 6 surface, 6 options. So of course, it's going to be like more. Okay, so the solution is hit on the second toss. They want us to calculate the P, the probability of A given by B. Okay, in this for the value, of course, right, because they have 4 possibility, probability. So of course one is 1/4, 1/4, 1/4, 1/4. Okay, in this case, we want PA given B. So what is PA? So of course you have to choose the PA given PB, right? Say what is the PA? Let's think. Any guesses? Head on second toss. How many? Only one, right? So it's going to be 1/4 divided by head on first toss. How many? 1/4 plus 1/4. So it's going to be equals to 1/2. So this is the value for. So you can calculate by yourself. It's a simple math, right? Okay. Okay, next up we have another exercise is the probability that a regularly scheduled flight departs on time is PD 0.83, and the probability that it arrives on time is PA, which is 0.82, and the probability that it departs and arrives on time is PD intercept A equals to 0.78. So find the probability that the plane arrive on time. So of course they want us to find the PA, right? So the PA equals to, so over here we have P D intercept A. Sorry, this is P, yeah? So divided by what did I mention just now? I mentioned previously that the things over here should be something that, okay, for example, right, okay, we have D and A. Of course we have D and A. So if let's say we want to find A, so over here should be the D, right? So in this case it should be 0.83 to be divided by 0.78 divided by 0.83. Okay, because this one applies, this one follows the formula of this conditional probabilities. All right, PA B equals to, oh, I'm sorry, actually it's supposed to be PA, hold on, this one should be P D, yeah, sorry, A, not D, okay? Don't even I get confused. don't get confused. A arrive on time given that it departed on time. Okay, it should be like this. This is the correct one. If you missed it, of course you're gonna miss the marks. And what about the B? Okay, so I bet that you must be able to come up with your with the solutions. Just change this one. So this D should be D per A equals to PD. So basically this is the same because of what? Because the intersect value is consistent. If let's say it's going to be D, but of course don't make sure how you want to define it. It's going to be, you cannot simply define it. For example, right, this is P D, make sure that it is D, D intersection A. Don't write it the other way around, but the value is consistent. So even though you want to find the value, if let's say they want, the plane has to arrive or the plane has to depart, as long as the probability that it departs and arrive on time is truly consistent. So the value for this one should be the same, except this one, which is the PA. So for the B, for the question B, you just change the D. You just change D here. Okay. Let me erase this and this one and this one also. Do I have another color? Okay, I have it. Okay, this is D A, and this one should be D. Yeah, sorry, A. Right, so the A is 0.82. Okay, so don't get confused. So that's all for this week. So during the class, we're gonna wrap everything up and we're gonna discuss together.